Hi, welcome to our very last Level 3 integration video. This video continues on from halfway through the problem in the last video. So far we were trying to write a differential equation, determine a particular solution, and use it to estimate the population of New Zealand in December 2025. Because we'd written New Zealand is growing at a rate that is proportional to the number of people living in New Zealand at that specific time, we decided to use this differential equation. dy over dx is equal to k times the function y. But we're changing y into p for population, and we're changing x into t for time. So we'd raced through all the algebra and we'd got to this stage so far. So let's continue. We're going to take this general solution and write it in a slightly different way. To do that, let's go back and revise our power rules. X to the power of n times x to the power of m is the same as x to the power of n plus m. Now, it doesn't matter whether we use e as our base, it's the same power rule. I'm just going to rewrite that a different way. E to the power of n plus m is equal to e to the power of n times e to the power of m. Now, if you look up above, that's how I've written the population function, e to the power of kt plus c. So what I'm going to do is rewrite this as population is equal to e to the power of kt times e to the power of c. Now, looking at the e to the power of c, we know e is a special number, but it's raised to the power of c, which is another number. And a number raised to the power of another number makes another number. So we're going to call e to the power of c the number a. And we're going to pop that out the front to write it as population is equal to a times e to the power of kt. Now, this is also the general solution written in a slightly different way, and it's the more common way we prefer to write these solutions. Right, well, this is the general solution. We're going to take this and find the particular solution for this information given. Here's all the information we were given. We're going to come up with a clever number line. To do that, we're going to start off and say December 2001 is the 0th year. We need a 0th year in these kind of problems. So that means 2006 is the 5th year and 2025 is the 24th year. So starting with the 0th year, let's put 3916000 in for the population and 0 in for time. Now we know k times 0 is 0 and e to the power of 0 is just 1. Any number to the power of 0 is 1. So we're going to end up with a is equal to 3,916,000. So we've figured out what a is for this information. Great, let's put a equal to 3916000 and let's move on and use the next bit of information to figure out k. So we're going to put 4,209,100 in for the population and we're going to put 5 in because we're saying 2006 is the 5th year for t. Now to solve this equation for k, let's quickly do that. We're going to divide both sides by 3916000. So we get 1.0748 is equal to e to the power of 5k. We're now going to take the log on the natural log of both sides. The natural log of the left is 0.07213. And when we take the natural log of this special number e, we just get 1. So that leaves us with 5k. Dividing both sides by 5, we end up with k is equal to 0.01443. Now I've rounded that to about 4 significant figures. Try and round it to at least 4 to be accurate. You will usually find k to be a very small decimal in these kind of problems. Right, well this is our particular solution. We finally got there. So let's look at our general solution and compare it with our particular solution for all the information given. We finally are ready to find out our estimate. So let's go back and use our particular solution and substitute in the 24th year for 2025. Using a calculator, we've estimated the population to be around about 5,536,656 people. This is really, really cool. And go back and watch the videos over the last 3 or 4 if you're really struggling. But thanks for watching and all the best with your exams.